Yeah, also thanks Jeremy for giving away my punchline from slide 2. But okay. Uh, my topic is titled Data is the New God. This is not in the religious sense God, but in a professional sense, in a business sense. Data is the new thing that we should worship, and data is what should have authority. Okay, that's what I'm talking about. Or more traditionally speaking, data driven decision making is what I'm going to talk about. Two. All right. Okay, so this is what Jeremy was talking about. So our theme for this evening, as you know, is productivity. Productivity has two sides. Now, if you can remember from one of Anjana's slides, he showed a car coming in, and you reduced the wastage, you focused your effort, and you automated things, and you made sure that you did the things right, you optimized it so you can do it as fast as possible. So that's one side. So that kind of nicely dovetails into what I'm going to talk about, which is the other side of the coin, which is doing the right thing. For example, let's say you build a car. You build a car really fast. You optimize the usage of your resources. You build it really fast, really well. But what you needed was a bus, right? So that's doing things right versus doing the right thing. So I'm going to talk about this. How do you decide what to do the right thing? How do you usually base it on a feeling, right? The right way to do this, folks, is with data. So that's what I'm going to talk about today. How to decide what to do and what to do first. Okay, so since I'm the last speaker and I know all of you are tired, I'm going to start by telling you a story. And actually, this whole presentation is actually two stories. I like to tell stories mostly. How many of you know who this person is? Anybody? Historical figure, well known. No? No? Florence Nightingale, yes. She's more known as the lady with the lamp because during the Crimean War in the late 1800s, she was known for saving a lot of lives as a nurse in the battlefield. And what she's most well known for is making the rounds in the night, very, very tirelessly working to go look at the soldiers, tend to their wounds and taking care of them. That's what she's known for. But what most people don't know is she is also the inventor of the infographic, data visualization. This is over 100 years ago. To me, she is basically one of the very first data scientists, because the problem that she faced was a very difficult one, which is in a time where people didn't understand that germs were the cause of infections. She had to convince an entire establishment that this is what the problem is. And just to give you an idea about how hard this problem was, the person who tried to do it before her was a physician, I can't remember his name. When he tried to tell the medical establishment of his day that part of the reason why patients were dying after surgeries was that doctors were not washing their hands, the entire medical establishment was so enraged that they worked against him, and this man who was trying to save people's lives was committed to a mental hospital. I'm not kidding. This actually happened. And this was one of the contemporaries of Florence Nightingale. So imagine, this is a time in a male-dominated society, in a war nonetheless, trying to convince politicians and military leaders that the way to save lives is to improve medical hygiene. Washing your hands, washing your instruments, dressing the wounds properly. So she had a huge job, where her predecessor was actually sent to a mental asylum for claiming that you need to wash your hands. The way she did it is not through rhetoric, not through back channels, not through having the right context, but with data. You recognize this one, right? It's a very modern looking infographic, but over 150 years old. So what it shows you is it's a diagram of causes of mortality in the battlefield. The years, months are represented as petals in this diagram, and each of these things show you what the causes of death were. This is just one representation, and using this and other graphs, she actually managed to convince the establishment that her methods have validity and they should implement those, and to have the funds to do that. And by those means, and a lot of people don't know this tragically, that by those means she saved way more lives than she saved by walking, making the rounds in the wards and tending to soldiers by herself. So that's a huge thing. That's a huge win for data, right? So that's how it's important. That's the power of data, folks. Okay, next one is also a story. The following exchange is based on true events that happened in this company, but the names and numbers are made up to hide the guilty parties and to hide our proprietary information as well. But the problems are real. A few months ago, okay, that's me. This is our Senior Vice President of Global Engineering, to whom we owe a lot of what we have achieved in this company. A certain problem came up. Actually, I was toying with this idea of how to improve performance in our front end, our system's front end, right? So I went to him and said, basically, I'll read the bubbles for you. We can greatly improve the performance of our product by introducing a more efficient transaction object format. You know, the transaction is most systems have a transaction. You store all the data in a transaction object, right? For the technical among you, this will be a JSON object. Think of it that way. There are all kinds of data inside. And now, since our system was built about 4 or 5 years ago, we have certain amounts of legacy data in this thing. It's not the most efficient thing. And I proposed that we can make this more optimized, right? And it's a somewhat complex job, since a lot of components read this object. So we have to refactor a lot of these things, right? And I wanted his permission to go ahead, form a team and do this. And he tells me, we should not shoot from the hip. You know what this means, is right? This phrase, shooting from the hip. In old cowboys, they have the holster here, and you do that. Whereas not pointing like this. The downside of this is, you're quick on the draw, but you're more likely to miss because you're not aiming. Whereas if you aim like this, you're slow, but you're more likely to hit your target. So that's what this means. What he wanted was, now I'm giving him like a very vague idea, right? Quantify greatly. Now I said greatly improve, and quantify more efficient. Give me numbers. And try to trace this problem that is in my head into actual performance production. Then we can go ahead. So I went back, did some number crunching with my team, and we came back with this. We tested the load and save times, because that's where the problems usually are in the system. Not in the CPU, but loading some data structure and saving it, that's where your time is spent. We found out that a typical large transaction, here's the difference. Using the older data format, a large transaction would take about 1 megabyte. I'm making these numbers up, right? Comparatively, the proportions are the same, but the units and other things I have changed a bit, so as to not reveal anything. Okay, 1 MB transaction object, to fetch it from the backend 900 milliseconds, to save to the backend 1200 milliseconds. If we cut out the fat with the optimized transaction format, 5-fold gain here, almost a 10-fold gain here, 5-fold gain here. So he says, yeah, that looks promising, but that's just one data point, right? Let's try to expand this, get more data points for different types of transactions. So I went back again. Some more number crunching later, we came back with this. We ran a series of tests with different sized transactions. Here's the load save times versus different sizes of transactions. We measure the size of transaction based on something called the item count. So smaller ones have 10 items, larger ones have 60 items. This shows you what the previous data object works. As the number of items grow, your load time increases, right? So a customer who is using a giant transaction, if he gets a large order, he has to wait for each one, he has to wait about a third of a second for his screen to load. So for somebody who's processing a large number of orders every day, this is slow. Whereas the new one is pretty constant. And I showed that even for save times, it's the same thing. Okay, now he says, now I'm convinced that large transactions will be a benefit, but how many of our customers actually create large transactions? If it's out of say 3,000-4,000, only 5 customers use this, is it worth spending our effort? So he wanted that as well. Now at this point I'm starting to get a bit annoyed, because why are we spending all this time doing these numbers, whereas we can go and build this, right? And you'll soon see why he was right and I was wrong. Even more number crunching later. What we did was we mined production data for about 3,000 customers running back 1 week, and we came up with a heat map of customer against what proportion of transactions are large. So these are the small ones. Item quantity less than 10, between 10 and 20, and these are the monster transactions like 50, 60. So we found out based on the heat map that there are people that use large transactions. So this is worthwhile. I mean, there are about 3,000 here, but I'm not showing those. So finally he says, great, we've got the data on the benefits, and we also now know how they apply in production. So we can go ahead, finally. So I go to my team and say, let us do a design and come up with the amount of effort involved. So we need to know how to schedule, right? So this is our architect. He goes on to look at the efforts, and he comes back and tells me, hold up, we found out something interesting during the effort estimation. Even though the performance gains that we expect are in the front end, most of our development effort is in the back end components. I mean, that's kind of a sign that we need to optimize our design. Yeah. Again, names are made up, but we have corresponding components, but they're not the same name, okay? And you can think of this as sprints or man days or whatnot, but the complexity and the effort. Front end about 5, local server, we have a local server to work offline about 5. Transaction processor 50, it's a backend component, reports 5, database schema changes 5, data migration about 30. So what he's saying is, even though our gain is here, a lot of the code changes are here. So maybe what that means is we need to dig into our design and see whether we can optimize it there. So all right, let's look at more alternative designs. He went back with the team, came back and said, we found that much of the memory processing savings that we are getting from this refactored transaction object is in just one substructure called the line item. And if you only optimize that, we can get 90% of the same gains, but without affecting the transaction processor, because the transaction processor doesn't look inside this item. We can change it. So we can cut out this effort entirely. So I had an idea when he said that. Can't we do the same thing for the data migration? You know what data migration is, right? You change your data structure from one to another. So you need to go and change all the data. So you have transactions that were created in the previous version of the system. You have to cater to those as well if the customer wants to load it. So there are 2 ways to do it. You need to go back and either transform all the old data to match the new format, or you build a new system that support both the new format but is also backwards compatible with the old format. So I thought maybe we can look at whether backward compatibility is the right way to go, whether it's more efficient to do it that way. So again they went back and came back and said, we add a little complexity to the front end because the front end now needs to handle both the old format and the new format, but we get rid of the data migration. And what we got at the end was almost a fourfold reduction in effort and impact. That's less development effort for the developers, also less testing for the QE, and less likelihood of production breakages once you send it to production, right? And we started work. Now imagine if I had shot from the hip and gone on and done it. Yeah, I would have spent the time that I would have saved the time that I spent on doing the initial analysis, but I would have lost a lot more doing the development and in production, right? So that is story number 2. And that is what you can do with data. And the important thing here, folks, is this. When you go up the hierarchy in your organization, you will find that the more your job resembles that of a salesman. Regular salesmen will sell the products and services. Your leadership team has to usually sell ideas. Ideas to investors, ideas to management, ideas to accounting to get resources. So that's what I basically did here, right? You need to be able to sell ideas. The way to do that is, again, not through rhetoric, not through yelling, not through back channel, but to have the data, because nobody is going to dispute the data. So use this. That's the power of data. And finally, you will notice that I really didn't use any fancy data analytics tools, right? I didn't use machine learning. I didn't use Spark clusters or whatnot. If you really think about it, these are the only data science tools you will need for 99% of cases. Write it down. Don't use it in your head. Write down your problems. Write down the numbers you have. Then use your brain, please. By brain, I mean you don't need calculus. You don't need all these statistical analysis. You can usually get away with basic things like averages, means, tables, sorting, filtering. That's mostly what you need. And if you can't do it in your head, this is my favorite data analytics tools, Excel or any other comparable spreadsheet. This can do almost everything that you want to do. And only if you can't do the job with these things, go for these fancy machine learning and all these stuff, right? That's all you need. And that, ladies and gentlemen, is my presentation for the day. Thank you.